How does an emperor penguin survive a fall down a 150-story skyscraper? This bird does it on a single breath, diving to 1,850 feet into the freezing Antarctic Ocean. At that depth, the water pressure exceeds 800 pounds per square inch. That's like a grand piano sitting on your thumbnail. Your lungs would collapse instantly. Yet, this penguin makes a living in the frigid waters of McMurdo Sound. So, how is this possible? Sunlight gives up at 600 feet, plunging the underwater world into absolute blackness. To hunt, the penguin relies on huge pupils to spot the faint shimmer of bioluminescent squid. Its body is a masterpiece of insulation, with over 100 feathers per square inch, creating a perfect pressure-proof seal. This isn't just a bird, it's a feathered submarine. While an Olympic swimmer maxes out around 5 miles per hour, this animal torpedoes through the Ross Sea at 9. Deep underwater, its physiology becomes genuinely weird. To save oxygen, its heart rate plummets from 60 beats per minute down to just 15. At 200 feet deep, its lungs completely collapse. This sounds catastrophic, but it's actually a genius trick to avoid fatal decompression sickness. Unlike other birds, its bones are solid, not hollow, to resist the crushing force. Its blood is also hyper-efficient, making up 15% of its body mass, more than double a human's 7%. This allows it to swim for miles under the Antarctic ice sheets, hunting for up to 30 wriggling fish before needing another breath. This animal doesn't just visit the abyss, it owns it. Storing nearly 47% of its total oxygen inside muscle tissue, the emperor penguin carries a biological scuba tank inside its flesh. While a human body holds just 15% of oxygen in muscle, this avian diver packs 10 times more myoglobin proteins than human muscle. What happens when oxygen runs out? A human brain faces irreversible cell damage after just 4 minutes without oxygen. Yet penguin nervous systems stay razor-sharp. How? Their muscles tolerate 3 times more lactic acid than human athletes before cramping. Red blood cells release 90% of their bound oxygen payload directly into working flippers. Swimming in ocean water at -1.8 degrees Celsius lowers their baseline metabolic demand by half. Down at 500 meters depth, hydrostatic pressure hits 56 atmospheres. A 3-centimeter layer of dense blubber prevents catastrophic heat loss in the Ross Sea. Out of every 100 deep dives, only 5 out of every 100 lungfuls of air remain in their squished lungs. A full-grown penguin circulates 5 liters of blood to keep vital organs running. Within 15 minutes of surfacing, they clear all metabolic waste before plunging into pitch-black water once again. But pressure is only half the battle. Their heart is about to do something medical science thought impossible. Dropping its ticker from 200 beats per minute down to 15, this bird goes full biological zombie mode underwater. Arteries to its gut constrict by 98%, flat out stopping blood flow to non-essentials. By clamping peripheral plumbing, 90% of oxygenated blood gets redirected straight to its brain. Yet its coronary arteries remain wide open to keep heart muscle alive. Wait, actually, how does it hunt like this? Descending past 1,500 feet into the dark, it chases Antarctic silverfish hiding under shelf ice. In 5 minutes on the floor, it gulps down 30 fish while nearly dead. Ever tried sprinting while holding your breath for 20 minutes? Lactic acid hits 20 millimoles per liter, a level that paralyzes human Olympic sprinters. Still operating on absolute biological oxygen reserves, its brain functions below 15 millimeters of mercury pressure. Myoglobin proteins in its muscle tissue bind oxygen so aggressively they dwarf human capacity by 10 times. To save precious energy, peripheral body parts cool to 4 degrees Celsius. basically a swimming refrigerator. Red cell concentration spikes 30% higher than other diving birds, turning blood into thick sludge. Researchers at McMurdo Sound tracked 100 dive profiles proving these birds defy textbook medicine. By completely collapsing its lungs prior to diving, the emperor penguin crushes its body to survive liquid abyss depths. At 50 meters below ice, hydrostatic pressure forces air into non-absorptive cartilaginous tubes. Wait, actually, only 1 in 20 human scuba divers could survive those pressure spikes without embolisms. Shrinking functional lung volume by 90% prevents fatal nitrogen gas bubbles during rapid ascents. Physiologist Gerald Kuhlman in 1970 first hypothesized this mechanism, which digital loggers later confirmed. 3 critical adaptations make this absurdity work: collapsible ribs, reinforced tracheas, and elastic air sacs. Below 200 meters, the bird glides downward, like an unhinged stealth missile, without flapping once. Commuting across 100 kilometers of frozen ocean, parents hunt bioluminescent squid in perpetual darkness. At maximum depth, water pressure exerts 53 atmospheres, pressing down with 750 pounds per square inch. How does anything survive that crushing force? One tagged emperor logged 3,000 deep dives over a single winter. Yet environmental shifts mean shrinking fast ice will force them into longer, grueling commutes. Marine scientist Paul Pogones noted, "These birds operate at physiological limits that would kill any terrestrial mammal in minutes." Staying submerged for 20 minutes, while plunging 1,850 feet, makes this bird evolution's weirdest submarine. Human neurologists now study their cellular oxygen management to revolutionize stroke care for 15 million patients every year. Plunging 1,850 feet underwater equals stacking 6 statues of liberty end to end straight down into dark ice. Surviving in the freezing Antarctic Ocean requires biological perfection, yet 4 whole colonies suffered total breeding failure across the Bering-Josen Sea. Releasing trapped plumage air slashes drag by 50%, shooting the bird onto ice like a launched rocket. Sleek, counter-shading camouflage protects returning hunters from predators lurking below. Parents navigate across McMurdo Sound, isolating their chicks' acoustic call among 10,000 screaming neighbors. Wait, actually, a single parent regurgitates 2 kilograms of digested krill after swimming 1,000 kilometers. That is like running across 5 states just to deliver dinner. Internal nasal heat exchangers capture 80% of exhaled thermal energy, while underwater turning radius contracts under 50 centimeters. According to British Antarctic survey records spanning 1901 to 2024, emperor colonies require stable sea ice for 9 full months. Bioengineers copied this hydrodynamic body design, reducing robotic submersible power consumption by 30%. Deep ocean tracking reveals stark metabolic differences between warm-blooded marine birds and land-dwelling mammals. What makes this tuxedo-wearing bird so ridiculously resilient? Evolution constructed an uncrushable submarine missile capable of diving 1,850 feet. Holding its breath longer than an elite Navy diver, this creature reigns supreme over Earth's cold frontier.